Okay guys, how are we? In this lesson we're looking at prime factor trees. So by our learning goal, calculating a number as a product. So there's a clue there of its prime factors using index notation. So remember, product is something that you get when you multiply two numbers together. We're looking for prime, that language is familiar, and index notation. So we're just bringing a couple of concepts together in this video. Our success criteria: find the prime factors of a number using factor trees and express those prime factors in index notation. So we get to write that down. Vocab. You have index notation, so remember it's that whole process of, instead of writing say 3 times 3 times 3, we can just say 3 to the power of 3 because it's been multiplied by itself 3 times. Factor, so a number that can be divided by another without any remainders. And prime number, so the numbers that are can only be divided by one and themselves. And a composite number is any one of those, any other number that has more than 2 factors. So getting into what we're doing, so we're looking at composite numbers, so those that have more than 2 factors. Mind you though, and factor trees, but you can use factor trees with prime numbers. It's just not going to be very tree-like. It's just going to be a fork. Alright, so using factors to determine the prime factors of the following. So use a factor tree, Just changing my pen to red here. So the first one we're going to do, I'm just going to put here and back to blue. Okay, so 80 is our number we're going to start off with, and I'm just going to write it up here. I'm going to think of any factor pair that I know 80 can be divided by. So I'm going to start with the easy one, 8 and 10. I would strongly recommend that you don't do 1 and the number itself, because you're only going to be where you were in the previous step. Anyway, so here we go. 80 is a product of 8 times 10. So when we construct these factor trees, we're getting it down to its prime factors. So that means that the last branches are prime numbers. So we're looking for 2, 3, 5, 7, 11, 13, 19. Just as a minimum. So there you go, some examples. So what I can see here is 8 and 10 are both composite numbers. So I'm going to see if I can find another factor pair for 8. And I'm going to break it down into 2 and 4. I'll leave this here for the moment. So 2 is now a prime number. I'm leaving that alone. And this 4 here, I know it is, it has factors of 2 times 2. So I'm going to write those in. And now I know that the 8, 2 times 2 times 2. And then I go to the other side. So any factors of 10 are going to be 2 and 5. So once I have that information there, that is a full factor tree. I'm going down to my prime factors. 2 are prime numbers, and so is 5. I'll leave my question as it is for now. The second one. So this is where your multiplication and your understanding of number facts and knowing what number can be divided by, so using the inverse or the opposite. So if I said 20 divided by 4, that you're able to recognize that 4 times 5 is 20. So making those links between division and multiplication. So 27 is our number that we've got here. I'm just going to write that in like we do with everything else. And we're going to find a factor pair. So straight away, I know 27 is 3 times 9. So I'm going to put 3 and 9 in. 3 is a prime number, so I'm going to leave that alone. And this 9 is not prime. So besides 1 and 9, 3 is a factor of 9. So my my factor tree for 27 is as shown. And then the last one is 32, question 3. Oops. And so we write our number down. and split it. Now 32 is a good example of what happens when you have lots of different factor pairs. Will it make a difference? And we'll have a look. So 32, I'm going to go and use 4 and 8. 4 as factors of 2 times 2. And the 8 is 4 times 2, and the 4 is 2 times 2. So I have this one here. But you'd be like, sorry, no, wait, what? How about 32 and it's 16 times 2? It will still give you this outcome because you keep looking until you get to no more prime factors. So 2 is already there. 16, I can go 4 times 4 or 8 times 2. And 8 times 2 would give us 8, 2, and so forth. And with this one here, I'm going to split that 4 times 4, and 4 times 4 is going to be 2 times 2, 2 times 2. If you have a look here, 1, 2, 3, 4, 5, and this is 1, 2, 3, 4, 5. So what we can do is we can take this information in the factor trees and use that to create our index notation. So I'm just going to leave that there for a moment. So with 80 here, it's going to equal. Now what I do is I count up my prime factors. So I'm just going to highlight my prime factors at the bottom of this one so I can see them. And a product just means multiplication. And I have a 2. And that is being multiplied by itself 1, 2, 3, 4 times. And a 5, which is multiplying the 2 to the power of 4. Next one, here we've got the base is 3. 1, 2, 3, and I have 3 of them. 3 to the power of 3 is 27. And then the last one here, we've got either one you can use. 1, 2, 3, 4, 5. So 32 is 2 to the power of 5. Okay, so there's your questions. Hopefully you'll be able to reach your learning goal, which is using finding prime factors, so using the factor trees and expressing them in index notation. There are your activities you need to do. Alright guys, thanks.